So with the roles we've developed now, we have uh, a lot of cool ways to build new series, but it turns out we can actually go even further. We have some more tools at our disposal. Turns out that if you have an infinite series that converges on I, some interval I, then the derivative of that function will also converge on I, and its series is just the derivative of the term-by-term derivatives of the power series, that infinite polynomial. And likewise, the integral will also converge across that interval I, and the integral is just the term-by-term integral of each of those different powers of x. Now, one important note, this result is true for the internal points of I. So if the original series included an endpoint or two, we don't know if that's going to be the case for their derivatives or integrals, because this result only holds for the internal points. Endpoints need to be checked separately if we're worried about those. So you would have to look at the series result you get and see, does that series work? Now, we're not really going to worry ourselves about that. We're just going to be concerned with the internal points of convergence. But that is an idea that is important there. Okay, that this only holds for the internal points only. So I just want to point that little detail out. But for us, that's not going to be really anything we worry about. So let's look at this and generate some new series. Once again, we have our good friend, the geometric series, which we know converges to 1 over 1 minus x, as long as the absolute value of x is less than 1. So let's compute a new series by using the derivative of that. So the derivative of 1 over 1 minus x would need to be the derivative of the series. The derivative of the series. X to the k. Again, as k goes from 0 to infinity. Okay, so let's start taking a look at that. So on the left-hand side, let's work out the derivative of this. Then we'll come back to the series in a moment. So the derivative, well, easiest way to do that derivative, I think, would be to first rewrite that as a quantity raised to the minus 1 power. And then we'll just use the chain rule to do its derivative. So multiply by the exponent, minus 1, drop the exponent by 1, minus 2, times the derivative of the inside. And so in the end, we get that the derivative of this is 1 over 1 minus x raised to the second power. Okay. 1 over 1 minus x raised to the second power. Okay. All right. So let's take a look and see what that's going to look like on the other side of this. Let's look at the series now. So the derivative of that, using the power rule, right, e dx of the series, x to the k, would be k x to the k minus 1. Okay, x to the k minus 1. Now we have to be a little careful here when we do this. The original series would have been 1 plus x squared. Right? 1 plus x squared plus x cubed, and so on. Right? That series would have started at 0. Right? Now that I've come down to k minus 1, though, now that I've come down to the k minus 1 series, again, the terms of my series are 0 plus the derivative of 1 plus 2x plus 3x squared, and so on. All right, I have to make a little adjustment here. If I start this series as k x to the k minus 1, then I would have to actually write it as the series starting at 1. Right? Because you can't put in 0 because 0 minus 1 would be 1 over x. That's not what we want. So now you can make adjustments to that. To get it to start at 0. All you'd have to do is just shift everything so it starts at 0. In other words, this would have to become k plus 1. K would become k plus 1. The k minus 1 would be back to a k. So if you wanted to start it at 0, you still could. But it's fine here. So that's the series for 1 over 1 minus x squared. Which again is the derivative of that. And that will converge as long as the absolute value of x is less than 1. Absolute value of x is less than 1. Okay? So again, we can leave it like that, or we could again adjust that to make it k go from 0 to infinity. Again, that would actually just be k plus 1. So, or we could do it as k going from 0 to infinity of k plus 1 x to the k. Right? So either one is fine. Fine with either one. They may be a little more picky some of the homework questions, wanting it to still be an interval from 0 to infinity, perhaps. So you should kind of pay attention to if the directions are a little more restrictive there.